Okay, quiet down, please. So last time we looked at the first method of solving these first order ODEs. So we know what first order means, we know what ODE means, and I said there were those different cases for solving them. So the first one we did when it was separable. So remember, separable means that f of xy that we had on the right can be separated into some g of x times h of y. And then we took all of the y stuff to one side, the x stuff to the other side, and we could solve that. We have two more to go through. The second one is when that right-hand side is homogeneous. We call it a homogeneous differential equation. And that's when we can take that right-hand side, f of xy, and write it as some function g of y over x. So whatever that function f of xy looks like, if we can write it like that g function, we call it homogeneous. And if it is homogeneous, there's a method that we can use to solve it. Okay, the third one is if that right-hand side is linear, and we're going to do that a bit later on. Okay, so let's have a look at the homogeneous case. So we've got y prime is equal to g of y over x. Okay, so that's special case. The way we solve this is by using a change of variables or a substitution. So whatever's inside there, that y over x, we're going to let that be u. So let u be equal to y over x. Okay. And we're going to treat y as a function of x. So we have y as a function of x over x, again, function of x. So u is now a function of x as well. So a little bit of rearranging here. We're going to get y is equal to u times x. And again, that u is a function of x from what we had before there. On this left-hand side, we need to find y prime. And on the right-hand side, we can just substitute u. Okay, so let's find y prime. Again, u is a function of x, so we need to use the product rule. So this is going to be u prime x plus u. Okay, that will take care of that left-hand side. And then the right-hand side, all we need to do is substitute u. So substituting into original differential equation. Okay, we get the following. That left-hand side, the y prime, becomes u prime x plus u. Okay, that was the left-hand side. And the right-hand side was g of y over x. That just becomes g of u. Okay, notice that there are no more y terms. So this is now a differential equation for u. Okay, so we're going to solve this one. And then right at the end, we're going to substitute back to get y. So solve this differential equation for u of x. Okay, but that was just a substitution. If we go back here, y is then u times x. So that gives us our final answer. And that gives us our answer there. So the hope is that whatever complicated right-hand side this becomes, okay, when we do this y over x, when we do the substitution, this over here becomes simple. Okay, that's the idea. Any questions about the method before we look at the examples? Okay, pretty straightforward method. You let u be y over x, and then you substitute for y over x and for y prime. Let's have a look at some examples. Okay, number one, y prime is equal to x squared plus y squared over xy. Okay, so this is a first order ODE, very, very much non-linear, okay, but we can handle that. So what we need to do is go through our checklist, okay, from the top to the bottom, to see what we can do. Because remember, in the test and stuff, I'm not going to tell you if it's separable or homogeneous. You just have a list, and the question says 12. Okay, so this one, maybe it is separable, and then we can do that. Otherwise, you check if it's homogeneous, then you do that. And then the last case we'll get to, you check if it's linear, and then you do that. Okay. So first thing, is this separable? Can we write this as a product of x and y? No. No, we can't, right? It's a sum. We've got some x terms, some y terms, and we're adding them. There's no way to write this as g of x times h of y. So we skip that. Okay. So it can't be separable. Now we check, is this homogeneous? Now, as written, it's very hard to tell because it's homogeneous only if we can write it like this with y of x. Okay, that's how we know. So here, not quite. Let's just do some rearranging. So we're going to take the x squared and divide it by the bottom part. We're going to take the y squared, divide it by the bottom part, and then we'll see what happens. So this is going to become x squared over xy. That will just be x over y. Y squared over xy. That will be y over x. Okay. Now this is in the correct form because if we let u be y over x, that first term is just 1 over u, and the second term is just u. So that's all fine. So here, if we let u be y over x, that one will be u, and then this will be 1 over u. So our g function for that right-hand side will be g of u is 1 over u plus u. Okay. Straightforward. So we're going to do that. So let u be y over x. That takes care of that right-hand side. Now for the left-hand side, we need y prime. A little bit of cross-multiplying. Y prime is u prime x plus u. It will always be that. Okay, so let's substitute for the left-hand side and the right-hand side and see what we get. Okay, and on the other side, we have 1 over u plus u. Okay, so this is nice. We got plus u on both sides. We can cancel those. So we end up with u prime x is 1 over u. Now we need to solve this differential equation. Now this one, with a little bit of rearranging, is then separable. So we started out with this being case 2, with it being homogeneous. We do some work, and now it becomes separable from case 1. So they mix in each other. We'll see for later on, we can do the substitution, and then it becomes linear. And then we have to do case 3. Okay, so it's not independent cases. They mix together. Okay, so again, notice this is separable. Okay, so let's write this u prime as du by dx. Okay, now we know it's separable, so let's do the rearranging. So the u stuff we'll take to the one side, and the x stuff we'll take to the other side. Okay, so all of the u terms are on one side, all of the x terms are now on the other side. Now we're missing the integral sign, so let's put that in. And whenever we do the integration, remember plus c. Okay, so 2 integrals to solve, very easy. So this one here, we get 1/2 u squared. Here we get the natural log of x plus c. Okay, the 2 we can take over. So we get u squared is 2 natural log of x plus 2 times c. I'm going to rename that back to c. And then finally, we can take the roots on both sides. So u of x will be plus or minus, because they're both squared to the same thing, 2 natural log of x plus c. Okay, but this was with our substitution u. We wanted the solution with y. If we go back a little bit, we see y is just u times x. So whatever we get at the end, we multiply by x, and that's our solution for y. So we get plus or minus x root 2 natural log of x plus c. Okay, so we get two solutions, one with the plus, one with the minus. And then again, c, we don't know what that is. We leave it as a constant. And if we are given an initial condition, we can then solve for c. Okay. Any questions for this first one? Okay. Pretty simple. Let's have a look at another example, number 2. Yeah, so we have y prime is equal to x minus y over x plus y. Yeah. Now with this one, again, we go through our checklist. It might be separable, might be homogeneous, might be linear. Again, we'll look at that later. So here, this is definitely not separable. We've got x minus y and x plus y, so that's not going to help us. But is it homogeneous? Okay, can we write this as something like y over x? In this form, can't really see that. We've got x minus y and x plus y. So it's not quite this. But what can we do to this right-hand side to make it look like that u term that we need? What's that? What can we do? So we've got this over here. We want it to look more like that, so we can do the substitution. Yeah, think about it. We're going to divide the top and bottom by x, because we got y over there. We want y over x, so we're just going to divide by x. So here we have y prime. So we're going to have a fraction over a fraction. So we have x minus y over x for the top fraction, and then x plus y over x for the bottom fraction. Okay. Now we can simplify that. So the top one, x over x, that will just be a 1. And then minus y over x, that will become u. Okay, and then in the bottom, x over x, that will become 1. And y over x, that will become u. Okay, so again, with these problems, that right-hand side will be some messy thing like that, but we want it to be y over x. Okay, so we need that over there. So it is homogeneous now. All of the variables are in the form y over x, so that's fine. So we can do the substitution. Okay, so y will be ux, y prime, u prime x plus u. Again, that's always the same. So this left-hand side, the y prime, that will become u prime x plus u. And the right-hand side, wherever you have the y over x, that will just be u. Any questions so far? No, okay. Okay. So let's take everything over to one side with the u's. We're going to have to do a little bit of simplifying, and then we'll see it's going to be separable. So we have u prime x equals 1 minus u over 1 plus u minus u. Okay, so this is separable because all of the u stuff is on one side and the x thing is on the other side. But it's on the wrong side, right? We put all the u's on that right side. The u should be on the left and the x should be on the right. So a little bit more work to do. So these two here, we need to combine into one fraction, and then we can take it over. So we have u prime x is equal to 1 minus u over 1 plus u minus. We want to combine it, so let's make it have the same denominator. Okay. So it'll be something like that. Now we can put these together. So we have 1 minus u minus minus u and then minus u squared. All over 1 plus u. Okay. So we're just combining everything into a single fraction. So we get u prime x is 1 minus 2u minus u squared over 1 plus u. Okay, so now that it's a single fraction, we can take it over to the other side. We get all the u stuff on the one side and all the x on the other side. So this becomes 1 plus u over 1 minus 2u minus u squared du. So all of the u stuff on the left and all of the x on the right. Okay. So again, u on the left, x on the right. We're missing the integral sign, so let's put that in. And whenever we integrate, we need a plus c. Okay. So we have something like that. Now the right side, the 1 over x, that will just be a natural log of x, easy enough. On the left side, we have a polynomial at the top, polynomial at the bottom. What does that mean? Partial fractions. Okay, like I said earlier, last time, you got something on the left, something on the right. You don't know what you're going to get, right? It can be a mix. So on the right side, it's pretty easy, but on the left, we have to do partial fractions. Okay. So here, partial fractions. So we're going to do that as a separate problem and then put everything together because that right side we know already, that's just the natural log. Okay, so we need to solve. So we have the integral 1 plus u over 1 minus 2u minus u squared du. Yeah, we need to figure this out. So let's think back to our partial fractions. Remember step 0, that was checking the degree of the numerator and denominator. So the top needs to have less degree than the bottom. Yeah, otherwise we have to do long division. Yeah. So the top one has degree 1, the bottom there has degree 2. So that's fine. Okay, we don't have to do the step 0. So we go right to step 1. The bottom part, we try and factor if possible. Okay, if you can factor it, you do that, and then we split it up. If you can't factor it, then we have other work to do. Okay, 1 minus 2u minus u squared. Can that be factored? Because if it can't be factored, we need to do something else. So check if that can be factored or not. So 1 minus 2u minus u squared. Okay, so while you check that, we can see here. Right, when in doubt, plot it, see what you get. So we have 1 minus 2x minus x squared. We got something like that. Okay, so what would those parts be at the bottom there? I see you on your calculators, the quadratic formula for the roots. These two. I mean, you know the quadratic formula, right? So what do we get? 1 plus root 2. So let's put that in here. Yep. So that's the one root there. And the other one? 1 minus root 2. Okay. So we factored that bottom part. Okay, so we got the two linear parts there. Negative 1 minus root 2. Like that. Okay. Everyone agree? Okay. So we got that the one root and the other root there. Okay, it splits up nicely. So what can we do next? Two linear terms in the bottom. How can we split this up? Okay, think back. It's not so far long ago. So we have linear at the top and two linear at the bottom. How do we split that? It was case 1 for partial fractions. Yeah, look back in your notes. That's fine. It was the case 1. I hope you didn't delete everything on the break. Partial fractions deletes. Okay, look back. Case 1, when we had the linear terms in the bottom. So case 2 was the quadratic. This is just the case 1. Yep. Yeah, good. So if it's a linear top part and two linear bottom parts, we can split this as A over the first one and B over the other one. Right, you just split it up like that with A and B. Okay, so for homework, you're going to find A and B. Very easy, you just cross multiply, solve for A and B. Solve for A and B for homework. Right, you know how to do that. Cross multiply, make it equal to the top parts, and then you get your A and B. It will be something with root 2. Something with 2's and root 2's there. Okay, and then after that's done, the integration, very easy. Natural log for the first one, natural log for the second one. So this will be A natural log for the first one, and B natural log for the second one. Okay. Now this is in terms of U. We wanted it with Y's and X's, so let's just substitute, and then we're done. Okay, so wherever we have a u, we just go back to y over x. Now, in this form, it's very difficult to solve for y. So last time we had some equation, we could say y equals something. This case, you can try to do that. It will be a little bit difficult, but we're just going to leave it like this. So we have this in terms of y, and then the right-hand side, let's just put that back. This is equal to the natural log of x plus c. We're going to just leave it like that. Okay, solving for y is too much work. We'll just leave it there. Okay, any questions for this one? Okay, and then just a reminder here, taking stuff over to one side, making these fractions, this partial fractions might come up a lot. Okay, because whatever you have on this right side, this over here, if this ends up being a fraction on the right side, when you take it over to the left-hand side, it's still going to be a fraction. And integrating a fraction, you need partial fractions. Okay, so just keep that in mind. Whatever fraction you have here, it's going to be a fraction on the other side as well. Okay. So there we just leave that. Any questions? Oh, good. Okay. Let's have a look at last one for this case. Okay, we have x y prime is equal to y natural log of x minus natural log of y. Now with an initial condition, so this becomes an initial value problem. Remember those names? So we have the differential equation, we have the initial condition, and together that is an initial value problem. Okay, which means once we've done all of the integration and we have something plus c, we need to use that initial condition to then solve for c. Okay, it's an extra step at the end. Okay, so we go through the list to see what type of differential equation this is. Is it separable? Is it homogeneous? So on. Is this separable? Not quite, right? We've got natural log of x minus natural log of y. Can't really make that into a product of two things, so we skip that. Is this homogeneous? A bit difficult to see like this, but we can make it homogeneous. So let's take all of the other things apart from y prime over to one side. So if y prime equals something, and then we'll see what we can do. So we have x y prime is equal to y natural log of x minus natural log of y. We'll take the x over. Okay, so we have y over x. That looks good. Okay, but the natural logs, that's still going to be an issue. What can we do with those two? What's that? Yeah, logos. So the difference will become a division. So we have y prime is equal to y over x, natural log of x over y. Okay, so the y over x, that will just be a u after we do the substitution, and x over y, that will be 1 over u. Okay, or we can flip it and put a minus sign in front, and then that will be u. So let u be y over x. Okay, and we know u y prime, that will be u prime x plus u. Again, it's always the same, u prime x plus u. So left-hand side, let's substitute. And right-hand side, let's substitute. So the y over x, that will become a u. And then the natural log of 1 over u, we can just put a minus sign in front and write it like that. Yeah. Now we have a new differential equation. The nice thing is this is separable. We can take all of the u stuff to one side and the x stuff to the other side. So it's separable. So let's do that. Yeah. So we have something like that. But that u stuff there, that's on the wrong side. We want it on the left side. And the x, that's on the wrong side. We want that on the right side. So I'm going to take the u natural log over to the other side. I'm going to keep the minus 1 there, just to make it a bit easier. So that comes with the du, and that comes with the dx. We're missing the integration, so let's put that in. And then a plus c is needed there. Right. Any questions so far? Oh, good. Okay, and then the minus, sorry, there. Okay, that right-hand side, pretty easy to do. Okay, just going to be minus natural log of x. Okay, easy enough. Left-hand side, a little bit more difficult. What can we do? Think back, you go through your list. Is it something we know already? Not really. Use substitution, bar parts. There's no trig, so we can skip all of that. Then we go to partial fractions. Can't do that. There's a natural log. So there's two things left. It's either a u substitution or it's integration by parts. Which one's easier to work with? U substitution. Okay. Now between those two, u and natural log of u, which one can we use for a u substitution? The natural log. Why? Because it becomes 1 over u, exactly, which we have at the bottom. So we're going to do that. Right, that's the steps you need to follow, right? You check, always check the easiest thing and then you work down. So u substitution would be the best. Well, I say u, let's call it t substitution. So we have du over u, natural log of u plus 1. So let's do a t substitution so we don't mix things up. So we let t be all of that natural log stuff. And then the dt, like we said, will be 1 over u. Okay, that takes care of everything there. So this will be the integral. The 1 over u du, that takes care with the dt. And then we just have 1 over t. Okay, very easy. Natural log of t. I'm not going to put the plus c because we already did that on the other side. But then we can put the natural log of u back there. So this will be the natural log of the natural log plus 1. Yeah. So again, depending on the problem, that right-hand side or the left-hand side, you might have to do a little bit more work to solve that. Okay, let's put all the stuff together. So on the one side, we have the natural log of the natural log of u plus 1. And on the other side, we had minus the natural log of x plus c. Okay. Now we're not done yet. That u was just a substitution. Let's put the y over x back there. So it will be the natural log of the natural log with y over x. Now here we can solve for y, so let's do that. We've got the natural log on both sides. We can get rid of that with the exponential. Yep. Very similar to what we did last time. So e to the minus natural log of x, that'll be 1 over x. And then e to the c, that's just a constant. We can just rename that back to c. Okay. And again, this c over here is a renaming of e to the c. You can call it a, doesn't matter. Okay. Now we have another natural log from the inside. We can do exponential again to get rid of that. Okay. Then we just take the 1 over to the other side times by x. We're done. And we end up with that. Okay, so this is for any c. We don't know what that is. But here we have an initial condition. Okay, y of 1 is 4. That will allow us to solve for c and get one particular solution. Okay, so y of 1 is 4. So wherever we have an x, we can put a 1. And then the y must then be 4. And we can solve for c. Okay, so y must be 4. C, we're trying to work that out, but we know x must be 1. So we just have e to the c. And the x on the outside there, that's also just 1. Okay, so that 1 doesn't do anything there, so we can drop that. Minus 1, take over to the other side, get 5. Okay, and again, we want c, so that will just be natural log of 5. And we're done. Okay, so we have our equation here for y, and the specific value of c that satisfies this initial condition. All right. Any questions for this one? Oh, good. Okay. 2 homework problems for you to try. Okay, if you need more, please go have a look at the tutorial. So we have y prime is equal to e to the y over x plus y over x. Okay, very simple. We can see right away y over x is going to be homogeneous. And number 2, we have y prime is equal to y x minus y over x squared. Okay, that will also be homogeneous, but you have a bit of algebra to do first. Right, we need to try split that up a bit, and then we'll get our y over x. Okay. Those do not come with initial conditions, so you'll have some plus c for both. Okay. Any questions for the homework? Okay. Again, if you need more, please look at the tutorial. Right. Anything before we move on? Okay. Yeah. So the final case, case 3. This is when the differential equation is linear. Yeah. And then when we say linear, remember first order linear ODE. So we shorten that to just linear. Okay. If you're confused with any of those words there, go back to the previous lecture, see what does first order mean, what does linear mean, what does ODE mean. But we're just going to call that linear. Okay, so a first order ODE is called linear if we can write it in the following way. Okay, so the first order ODE is linear when we can write it as. Now this is called the standard form for it. Okay, so whenever you have a linear ODE, please convert it to the standard form before doing anything else. So we write it as y prime plus some function p of x, it can be anything, times y is equal to q of x. Again, that can be anything. This is the standard form. So please put a box around that. It has to be in this form. Otherwise, the method afterwards, it will just give you rubbish. Okay, so always make sure it's in this form before going through with the method. Again, please, lots of warnings there. Okay, you do not want 0 from line 1. Okay, so how do we solve this? So let's rewrite it. There's something we need to notice. And once we notice that, it becomes very easy. So we're going to rewrite it as y prime plus p of x. Again, it can be anything. There's no restrictions on what p can be. Now, the main thing that we need to notice, and that will solve everything, is that left-hand side looks very close to the product rule. The left-hand side, it's not quite, but it looks close. So it looks close to having used the product rule. What was that? Gee. Email. Okay, so it looks very close to having used the product rule. Okay, so what do I mean by that? So let's say we have the product of some function times y. So in the textbook, you'll see it like this. So the function mu, Greek letter mu, in other textbooks and online, it might be given by a capital I. Yeah, but it means the same thing. So we're going to use this. That's what's in the textbook. Others will use a capital I. So we have this. We're going to do the derivative of this product. Prime. What do we get? We're going to do it in a particular order, so it matches what we have at the top there. We're going to leave the first term and then derive the second term. Plus, then we're going to derive the first term and leave the second term. Okay, so we have something like that. So notice, we'll do a bit of color coding here. So the first term has the y prime over there. So let's put that in blue. That matches with this y prime over here. Okay, then in pink, we have something in front of the y prime, but in the original equation there, there's just the one there. Okay. And now for the next two, we're going to need some other colors. So let's do the y in green. That matches up with this y in green. And we need one more color. Let's do red. This derivative here, mu prime there, that's going to match up with the key that we have there. Okay. But again, I emphasize here, this is close to having used the product rule. Why do I say that? Well, this mu function there, we put that ourselves, right? That never existed at the beginning. Okay, so how can we fix that? If we just multiplied the one side by mu, we have to do the same to the other side. So we're going to do that. We're going to multiply both sides by this function mu, and then we'll see that solves the problem. Okay, so we're going to multiply both sides of the differential equation by mu of x to get this product rule that we want. Okay, so let's do that. We'll take this original function, original differential equation. On the left side, we multiply by mu. On the right side, we also multiply by mu. Okay. So haven't done anything there, because we did whatever we did on the one side, we did to the other, so we haven't changed anything. But now we can go back to our color coding here and match it with this new equation. So again, the y prime in blue, that goes here. And this mu that we had there, that goes there. And then same for the other one. We have this y in green, that matches up here. Okay, and whatever was in front of the y, that was in red, that's going to match up here. Okay. Does everyone see that? Matching up with the colors? Yeah. So we're just matching up. Whatever is in front of y prime, we match up there. Whatever is in front of y, we match up there. But now this left-hand side here, matching up with this left-hand side here, is just the derivative of these two. Okay, provided we match up the other ones as well. So here, the left-hand side matches. Right, those two left-hand sides there will match. If what? Well, if we're matching them up, the pink must match the pink, the red must match the red for them to be the same. So pink with pink, that's fine. Blue with blue, that's fine. red with red, that's not fine. They look different. But if we want the left-hand sides to match up, those reds better be the same. Yeah. Does everyone see that? For us to match up the left-hand side for the first equation with the left-hand side of the second equation, those red parts must be the same. Okay, so let's carry on. So what was the left side? That was mu of x times y, all of that prime. Okay. And this must be equal to that right-hand side. So we just matched up. Left side matched up, right side matched up. Now we have the derivative of this is equal to that right-hand side. Remember, we want to solve for y. So how do we undo the derivative? Integration. Yeah, we're going to integrate both sides. And because we did the integral, we need a plus c. And finally, this mu in front there, we don't want that. We're going to divide both sides, and that gives us our solution y. Okay, and please put a big box around that. That won't be given to you. You need to know that. Okay, so please put a big box. Okay, so that's box number 1. We got box number 2 coming. Now this mu here, we multiplied both sides by it, but we have no idea what it is. We're going to use this over here to figure that out. Okay. So let's go back to what we had there. So I'm just rewriting this. So mu prime equals mu of x times p of x. Okay, this looks pretty simple. Okay. I'm going to do a slight change of notation there. Instead of mu prime, I'm going to put d mu by dx. And then on the other side, instead of mu of x, I'm just going to write mu. Okay, so it looks a little bit simpler now. What type of differential equation is this? Separable, yeah. Look at the right side. It's mu times something with x, separable. So we're going to separate this out. All the mu stuff we're going to take to one side, all of the x stuff we're going to take to the other side. Now we're missing the integration. Okay. The integral of d mu over mu, it's just the natural log. This right-hand side, we don't know what p is, so we're going to leave it like that. But now, finally, we can solve for mu. So this will be the exponential of the integral. And please put a box around that. So this box in blue, over there, we see we have everything that's given. The the Q there. That mu part, we don't know what that is from that box. But then if you put that together with this pink box, we have everything. Okay, so the first box has the Q from the right-hand side, and then this box over here has the P from the left-hand side, from our original equation. Again, that's not given to you. You need to know these two equations. Yeah, and then just a little bit of terminology. This pink box here, that function is called the integrating factor. Okay. So if you're looking elsewhere, the notations for this is mu, like we have, and in the textbook, a capital I for integrating factor, you'll see, or IF, capital I, capital F, you'll see it like that as well. They all mean the same thing, and that is e to the integral of p of x dx. All right. Any questions about the method before we get to the examples? All good. Okay, let's have a look at the examples. Okay, 3 examples, then we can go home. Yeah, did you guys check your schedule to see if we could move this period? Okay, you got your WhatsApp group or whatever, you can discuss. If everyone is free for a double somewhere else in the week, we can move it if you want. I see a lot of you look tired by 2 o'clock. Okay, but some of you do chemical, some electrical, so you got different timetables. If you can work something out, maybe Monday you've got a double free or something, we can move it then. Okay. Otherwise, we just have to deal with 2 o'clock to 4 o'clock time. See, already yawning. I'm also yawning, don't worry. Okay, examples, 3 of them. Let's have a look. Again, if you need more examples, please look in the tutorial. There's plenty there. Okay, so we have y prime plus y over x is equal to 3x. Okay, so now pretend we don't know that this is linear. We go through the cases step by step. So is this separable? No, not separable, right? It's going to be a sum or difference with the x and the y. Okay, so it's not separable. Is this homogeneous? No, that's not going to work. We have y over x. That looks good. But on the other side, it's just x. That doesn't work. Okay. Is this linear? Can we write it as some function p times y and everything else is just q? Yes. Yeah. So p we can write as 1 over x times y just by itself. Everything else on the other side, that's q. So it's fine. So this is linear. And remember, it must be in the form y prime plus py equals q. Yeah, so that's fine. We can treat it as a linear ODE. Okay, so let's go through the steps. Step number 1 is to find that integrating factor. So we go back over here. So we find this integrating factor mu. That's step 1. And then step 2, we substitute it over here inside this integral and over here outside. And then we just do that integral of mu times q, and then we're done. Okay, 2 steps and we're done. Okay, the steps might not be easy, but at least there's just 2 of them. Okay, integrating factor. So mu is e to the integral p of x dx. Now, this p, remember, can be anything. Okay. There's no restrictions on what that can be. In this case, it's just 1 over x, so it's pretty simple. So this will be e to the integral 1 over x dx. So 1 over x, that becomes the natural log. but e to the natural log, that cancels. We just have x. Okay, nice and straightforward. Now the problem is, if this first bit was wrong with the integral, then we're taking this wrong integrating factor and substituting it over here. Right? Over there, the mu times q. So if you get the mu wrong, this integral over there could be much harder than it should be. Okay, because your mu was wrong. So please always double check that first integral before you substitute. Okay, otherwise that integral in the square brackets will be terribly difficult and you're not going to make any progress. Okay, so again, always double check before moving on. All right, otherwise you're just wasting your time. You're going to get to the second integral, spend 10 minutes, maybe you made a sign mistake in the previous one. So always double check. Okay. It's even a tiny sign mistake. Let's say you put a minus in front here. E to the minus natural log of x will be 1 over x. Right? X to 1 over x, that could completely mess up the second integral. Yeah, just from a single sign mistake. So always double check. But here, everything is fine. Let's carry on. So y of x will be equal to 1 over whatever we just found. Square brackets. The integral of what we just found, not 1 over, the integral of what we found there, times q of x, whatever's on the right, plus c. Okay, please do not forget the plus c inside the square brackets. If you put the plus c outside the square brackets, it's completely wrong. Okay, so please, inside the brackets. Okay. So that just becomes 3x squared. Pretty easy to do. Okay. And don't forget to carry the plus c down. So integral, that will just be x cubed. Okay. So we get x squared plus c over x. Okay, and if we had some initial condition, we could then solve for c. Here, there is no initial condition, so we just leave it like that. Yeah. Again, same 2 steps as always. Step 1, find the integrating factor. Again, double check your work there. And then step 2, substitute into that blue box that we had, and then evaluate the second integral. Okay, there's always the 2 integrals to do. Right. Any questions? All good. Okay. Let's have a look at another one. Okay, here we have y prime plus 3y equals e to the 2x. Okay, again, we go through the list. Is it separable? Is it homogeneous? Okay, so no, it is linear, so we can do that. Is it in standard form? Yes. Y prime plus p times y equals q, so everything's fine. So this over here is our p, this over here is our q. Okay, step 1, integrating factor. Easy there. Okay. Again, could be much more difficult, but this one's pretty easy. We've got our integrating factor, so integral number 1 is done. Next, we take this integrating factor and substitute it to get y. So this will be 1 over the integrating factor, big square brackets. Then we have the integral of the integrating factor times q which was e to the 2x, then plus c, then close brackets. Okay. Two exponentials. Okay, we can put those together. So this will be e to the minus 3x, integral e to the 5x. Sorry, that's a 5. Plus c. So e to the minus 3x. Easy enough, we just take the 5 down. So 1 over 5, e to the 5x plus c. And then we can put the exponential inside. Okay. And you see why it's important to put the plus c on the inside of the brackets, not on the outside. If you had it on the outside, then you would just have 1 over 5 e to the 2x plus c on the outside. Okay, so please be careful of that. And again, if you had some initial condition, you could then solve for c. Okay. Any questions for this one? All good. Okay. Last one for today. We have y prime minus y tan x equals 1. Okay. Again, go through the list. Is it separable? No. Homogeneous? No. Linear? Yes. Is it in standard form? Yes. On the left side, we have our p minus tan x. Please do not forget the minus sign. And on the right side, we have q. That's just 1. Okay, so step 1, integrating factor. That's e to the minus integral tan x dx. Again, it is the minus that we take there. Please do not forget that. Okay, because you make a sign mistake over there, then your integrating factor is wrong, and then the next integral could be impossible to do. Okay, so please remember any minus signs that come in front here. Okay, e to the minus integral, or we can do this one directly, integral of tan. I think way back when we did the trig integrals. Natural log of sec. Yeah. Yeah. Okay. Again, depending on what these functions are, you might have some trig integral to do. You might have some partial fractions, whatever. All of that still applies. Here we had a trig integral. Okay. And now again, this minus sign, before it causes us problems, let's take the minus sign inside the log. So it will be sec to the minus 1. That will be cos. Yeah. Yeah. So that saves us from having issues with the minus there. So e to the natural log cancels, and we just have cos. Okay, so you see that minus sign is important there. If you forgot the minus sign, you would end up with sec, and then your integral coming up, might be very difficult. Okay, so again, please remember that. Now we can write out our solution. So this will be 1 over the integrating factor we just found. Big square brackets. The integral of the integrating factor times q, but that's just 1, so that's fine, plus c, and then close square brackets. Okay, so this will be sec x, integral of cos, sin. Okay, please don't forget that one. Plus c. So we get sec x sin x plus c sec x. Okay, now maybe for a test or something, I'll put there q is x, let's say. So if q is x, then we have the integral of cos x times x. So then for this integral, number 2 here, you would then have to do integration by parts. Okay, so depending on what you're given, it might be more difficult, less difficult, right? Depends on the p and the q. Right, any questions for this one? Oh, good. Okay. So next week, that will be the start of the tutorials. You have it on the Tuesday. Yeah, Tuesday, 8:40. The MCQ part, that's going to be on this stuff over here. Over here. Right, all the terminology and theory stuff we went through. So is something first order? Is it second order? Is it linear? Is it non-linear? Is it an ODE or a PDE? Right, all of this stuff here. Okay, that's going to be the MCQ, right? Just picking A, B, C, D. And then the written part will just be solving a differential equation. It will be either separable, like we had last time, or homogeneous or linear. Okay, will be one of those. But I don't say which one's which. I just say, solve this one, you solve it. Now, something important about the bonus marks and all of that. Sometimes a differential equation can be solved 2 different ways. You can solve it using separable differential equation, separation of variables. It might also be linear. You can solve it 2 different ways. Guess what happens when you can solve it 2 different ways? You get the marks for both. So please keep an eye out for that. So let's say you can solve it using separation of variables. You do that first because that one's easier to do. Get your answer. Then afterwards, you do it using this integrating factor. Get your answer. You get the marks for both. Yeah, same thing for the test coming up. Right? Do it multiple ways. You get the marks. Then we're going to be starting with the second order differential equations. Not too much, just a little bit for the electrical engineers. And then we're going to look at the Laplace transform for differential equations. So if you forgot your stuff with Laplace transform, please go over that on the weekend. Right. Any questions? All good? Yeah. I'll see you on Tuesday.